5.7 Interpretation of graphs. So we should be able to go from a graph to an equation, and the way to do that is to think about some of the key features that graphs have and use them to your advantage. So looking at a parabola, the most important part of a parabola would be the vertex. So if you can find a vertex, and you would be able to use this little formula here, and that should help you get the final equation. So looking at this, the vertex is at 4, 1. So the vertex is the h and the k. So that leaves me with this then. We can do x minus 4 squared plus k equal to 1. And then I still need to figure out what a is. And there's more than one way to do it, but if you're given a point 3, 4, so if we are given the point 3, 4, then with this x value you should get that y value. So y should be 4 when x is 3. Okay, so solve. So we get 3 on this side. 3 minus 4 is a negative 1 squared is 1, so a ends up being 3. And then make sure that you finalize or write your final answer by plugging in a where it belongs. So y equals 3, that's what a is worth, and then x minus h, and h is 4 plus 1, and it is a quadratic. So then that's your final answer. Okay. I think we're going to do that once more. Nope, we're moving over to the hyperbolic function. So an hyperbolic function has asymptotes. And you can use the asymptotes to get most of the structure again. So you can assume that the asymptotes are at whole numbers when we do these types of problems. So it makes this one at 2, and it makes this one at 2. So this is the line y equals 2, and this one crosses the x-axis at 2. Alright, so that helps you because the overall structure looks a little bit like this. And we know that this 2 over here is that k, so that's a over, and then we'll work on the bottom here in a second. And then here, h is your x value that you have over here. So we're going to write x minus 2. Okay, so the vertical asymptote, the x value that you have here, that is h, and for the horizontal asymptote, the y value that they give you here, that would be k. And then we do the same thing we did above. That would be one way to do it, and I'll show you the other way here in a second. So pick either one of the points. So let's use b for this one, so you don't have to always use a. So if 1, 1 is a point, then when you plug in a y, or when you plug in a value of 1 for your x, you should get a 1 for your y. So 1 equals a over 1 minus 2 plus 2. That's a negative 1, so this will be 1 equals a negative a plus 2. Subtract 2 on both sides. A negative 1 is a negative a. So for this one, a was 1. And then again, make sure you write your final answer with 1 over x minus 2 plus 2. Okay, and then we did talk about this when we graphed it. So if you start at like the new origin and you go 1 to the right and you go 1 up, then a is going to be the product of those two numbers. So 1 times 1 is 1. That would be the other way to do it. This way, you do have to be very aware of where the parabolas are. So in this case, a needed to be positive. If the parabolas had been here, a would have had to be negative, right? A on this one would have been a negative 1. You won't get that necessarily out of the, 1 over 1 up, 1 times 1 is 1, because 1 over 1 up and 1 times 1 is still 1. So if you solve for it, the negative comes with you for free, sort of. So, different ways of doing it. Either one will work if you're aware of what you're looking for. Alright, an exponential function. So the first thing that we really need to look for are the is the base, and then you do want to look at your asymptote. Now this one only has a horizontal asymptote, so then the horizontal asymptote. And to find the base, you need to use the 3 points that are given to you. You need to make sure you put them in order. What I mean with that is you have to go from left to right. So, you know, A happens to be 0, -1, but even if this had been A, that had been B, and that had been C, you really need to go in left to right order. So 0, 1, 1, 1, and then 2, 5. Okay, to find the base, then you look at the changes. If you're going by ones here, you're looking at the changes over here. So -1 plus 2 is 1, and 1 plus 4 is 5, and then A will be this one divided by that one. So 4 over 2 is 2. So we know at this point then that we have a base of 2. So this is our guess. This is not going to be right, but we are guessing it is y equals 2 to the power of x. Okay, now we're going to look at our asymptotes. Again, you may assume that it's a whole number. Okay, so the asymptote here seems to be at a -3. So that means that my next guess, and again this is still a guess, my next guess is, well, I should have an asymptote at a -3. So if it's a base 2, then it needs to be this one. And now we're going to check that. So we're going to use 0, 1. 0, -1. So again, that's the x and that's the y. So -1 when you plug in a 0 for x. And so we get a -1, and 1 minus 3 is a -2. And -1 is not a -2. So this guess wasn't right. So let's try another thing then. So what we're going to do then is say, well, let's just figure out what exponent needed to be on this 2 to make this work at 0, -1. So I'm still going to use 0, -1. Okay? So I want to get a -1 when I use 0 here as an exponent. So we're going to just figure out what exponent I really needed to make this come out at a -1. Alright, so at 3 on both sides. So I get 2 equals 2 to the power of b. That's a 1. So I needed an exponent of 1. So that is what I needed. So if you start with 0, so this is what you need, and you start with an exponent of 0, what do you need to do to 0 to make it worth 1? Well, I would say you have to add 1. Right? 0 plus 1 is 1. So here's my next guess. So instead of writing y equals 2x, I'm going to say this is y equals 2x plus 1 minus 3. Okay, that did work for 0, because if you now plug in a 0, you get 0 plus 1 is 1, and 2 minus 3 is a -1. So it works. I would check that one more time. Okay, so I would check that, and I would use a different value to check now. So we use 0, -1 here. So let's use 1, 1. And let's see if it works. So if I plug in a 1, I should get 1 out of it, right? So 1 plus 1 here, because that's the x that I'm using, 1 plus 1. And so 2 squared is 4, and so 1 does equal 4 minus 3. So that's it. That is the equation that I was looking for. So this one's a little more complicated. It's a bit of a puzzle, especially when I make the graph go from left to right. So notice here that the x plus 1 represents a shift left 1. Okay, and finally, we can combine these into finding coordinates and finding distances and a whole bunch of other stuff. So let's see if we can come up with some easy ones first. So let's look, for example, here. E is on the parabola here. It's on the parabola of a -x squared plus 4. We know that at E, the x value is 0. So when you plug that in, -0 squared plus 4 is equal to 4. So E needs to be 4. Okay. C is the y-intercept for the straight line x minus 2. Well, that means that it's 0, -2, because again it's on the y-axis, so it's a -2. Okay, so those are easy. A is probably one of the harder ones. I can find B several ways, and I can find D based on B as well. So let's see. One way that you can find B is on an axis again, right? So since it's the x-intercept for both the quadratic and the straight line, it's the x-intercept for f of x is x minus 2, you know that it has a 0 at the y spot. So you can write 0 equals x minus 2. moved to the other side, so then you get x is equal to 2. So that makes B then the point 2, 0. Because your vertex is right here on the axis, then the distance from here to here is 2, then the distance from here to here must be 2. So D must be a negative 2, 0, and that has to do with symmetry of the parabola. So you get that one for free. Okay? So then we're left with A. Alright, so how do you find A? Well, one way that you can do it is to say that f of x is equal to g of x. So that means that the straight line is equal to the quadratic equation. And then solve this. So bring this across. So that's x squared plus x. And then minus 4. So that becomes minus x is equal to 0. You can solve that by factoring it. It's an x plus 3 times an x minus 2 is equal to 0. So either x is 2. Okay, that would be here at b. Right? So we don't need that one because that's at b and we already have it. Or x is a negative 3. So the x value for A must be a negative 3. So how do you find the y value? Well, just plug it in, and it's the easier of the two is to use probably this one. So when you plug in a negative 3, you get a negative 3 minus 2 is equal to a negative 5. And that's your last point. Okay? Alright, now the distances. So first one says the distance from C to E. Well, that's straightforward because you can literally count up 2 and then up 4 more. So the distance from C to E has to be 6. The distance from A to B is going to be a little bit more difficult because that distance does not, although it's a straight line, it does not run along the axis. So what we need to do is we need to make a little right triangle out of this. And again, there's more than one way to do this, but I'm going to use this method. So if I make that into a right triangle with a right angle here, if I knew what this side was, and if I know what this side is, then I can find this side, because a squared plus b squared is c squared. Well, I know how much a is, or the distance is, because a, the coordinates there were negative 3, negative 5, and the coordinates for b were 2, 0. Okay? So A is the distance from a negative 3 out to 2 horizontally. So it's 3 to get back to 0 and 2 more here, so that's a distance of 5. B is the distance from a negative 5 up to the x-axis, so that one's easier to see, and that's also 5. So then you can say that c squared is equal to a squared plus b squared, Pythagorean theorem. So c squared is 5 squared is 25 plus 25, so I have two 25s there. So that's going to be 50, right? And then you take the square root of that. So the square root of 50. Don't need a plus or minus because I want a positive value because it's a distance. And then I just said it's two 25s, right? So 50 is two 25s. Well, the square root of 25 is 5, so you should reduce this to 5 squared of 2. So the distance from A to B is going to be 5 square root of 2. And that's it. Thanks.